Hello, my name is Soham. This is my BME 688 project, and this is the demo video for it. So, getting the code from my repository, to start it up, you'll have to use node, and we'll start the server.js file. So, a brief description of how all of this works. In the server.js file, we're creating an HTTP server that is sending out the data to the client every 10 seconds. And we have a reader.js file which uses the serial port library to get the data from the BME 688. And it does a lot of conversion to take the gas sensitivity, the gas resistance into the actual air quality index. And then on the client side, we have a graph.html. It has a canvas, and we're using chart.js, which is a library that makes a chart from a canvas. And the client.js just gets data from the server every 10 seconds and fills the graph out with that data. So I have my private IP open on the port that my server is sharing. So in 10 seconds, the graph will update. So let's look at temperature. We can toggle the graphs by clicking on the headers. One thing is that the server won't start reading unless you reset the BME 688. So it should start reading now. And there's our first data point at 0 minutes. We have 82 degrees. We'll test that, and it is 82 degrees outside today. So, and then we'll test humidity. I have a spray bottle thing. So humidity is relative. It's the relative humidity in percentage. So let's try to increase it with diffuser. And there we go. We've tested it out, and we can see we have a spike in humidity. It went up by 6%. Then we have pressure. This is measured in millibars or hectopascals. So 1 bar is equal to 1 atmosphere. So we can see it's 1,000 millibars. So that is about 1 atmosphere. And I don't really have a way to test that. Next we have air quality, and the air quality is moving average. So this is what I think is this is the main feature of my project. So using the gas resistance we got from the BMI, we can put it in an air quality index. So the air quality index is measured from 0 to 500. 0 being perfect air, it's totally good for you. 500 being horrible, get out of there. So a Sharpie has some pretty bad chemicals within it. So what we will do is we will see if the air quality goes up, meaning that it is decreasing in quality. So if I put a Sharpie really close to it, it should detect the VOCs, volatile organic compounds. And we'll just wait for a moment. And we can see it has made a small spike by 2 degrees. So what's the air quality moving average? So it takes the last 6 data points. So we can see here there's no air quality moving average, but here it will show the average of the last 6 data points and plot it. So there is this sort of theory slash idea that essentially whenever the list of data has a cross point such as this, and it goes above that, it's proposed that the the current data is really likely to go up. So say an intersection like this happens and we can see that the data is going below the average line, so we can predict that it will fall a lot. Here is another cross point. So if it goes above it, we may expect it, oh, and it did not cross. So it's not a perfect method, but using AI, this could be used for detecting forest fires that are incoming, and you might detect that the air quality is getting really bad with the temperatures uh, increasing. So it's a very useful tool, and yeah, thank you.